Hello everyone, let's look at puzzle number 5. So in this one, as discussed in class, you actually have a method for cheating a little bit and knowing the vertex right away. So it is given as parenthesis with an x being changed, and then you have a +3 on the outside. So the x has shifted 2 to the right, and then our vertex has shifted also up 3. You'll notice that this is given in a different form other than standard form. This is called vertex form from very early on your cover sheet. So it's given to us in this special vertex form where the h value is the x value of the vertex and the k value is the y value of the vertex. And you'll also notice that even though there's not this a value sitting out front, that therefore we can assume that that is just simply 1 sitting out in front, just like we did in that last problem. So you've seen all 3 forms of a quadratic now. You have seen standard form, you have seen factored form in that last one here, so that was given as another form. Now we could convert this to standard form by doing our double rainbows and expanding it out, and now you have also seen vertex form here, which we could also expand out with double rainbows. So remember, algebra whole, don't distribute this 2 with rainbows. This is x minus 2, so it actually is double rainbows. And then you have the +3 at the end. So standard form would be x squared minus 4x plus 7. And that parabola, that should be a 7, that parabola is exactly the same as this parabola. And I can prove that on Desmos. So if I go here and I do x minus 2 squared plus 3, and I compare that to x squared plus 4x plus 7. Is that minus 4x? There we go. X squared minus 4x plus 7. You can see that they overlap. They're exactly the same parabola. It's just manipulated into a different form, like the same thing as what we did with lines, the 3 forms of lines. So I can circle that this was given in another form. It was vertex form. And I can start cheating on my parabola. So I know that my vertex is at 2, 3, and my a value is 1. So over 1, up 1, over 2, up 4, over 1, up 1, over 2, up 4. And so I have my vertex centered in my table, then over 1, up 1, over 2, up 4. Therefore, I know the vertex, and because I know the vertex, I know that my minimum y value is 3, so my range is y is above 3, and I know since our axis of symmetry is sitting over at 2, right here, I can put that my axis of symmetry is equal to 2. Slope not relevant, the a value is equal to 1, and we have concave up. Domain all real numbers, because it goes all the way left and all the way right, there's no x values that would blow this up. There's no x-intercepts, and I can actually prove that the x-intercept happens when y is equal to 0. And if I set that equal to 0 and subtract 3 on both sides, the next thing I would do is undo this 2 by taking the square root of both sides. And I can't take the square root of a negative. There's nothing times itself that will equal a negative. So this is no real solutions both algebraically and we can see it graphically. And then the y-intercept we can see in our table. The y-intercept happens when x is 0, y is equal to 7. So our y-intercept is 0, 7. Reading function notation, I'm going to substitute 7 in for x. 7 minus 2 is 5. 5 squared is 25. 25 plus 3 is 28. We get as the y value. I labeled all my rates of change, reading it left to right. So start to the left, and I'm moving down. I stop, and then I move up. Thinking about function notation, our vertex from the original, which was just x squared at 0, 0, got shifted up 3 and to the right by 2. And then last but not least, this is one that's a really good one to practice your PEMDAS backwards because there's only a single variable. So subtract 3 on both sides, then undo this square by taking the square root. It can be both positive and negative the square root of 1. So I have either x minus 2 equals positive 1 or x minus 2 equals negative 1. Therefore, x equals either 3 or 1. And we can see that in the table right here. When does our pattern hit 4? It hits 4 when x equals 1 and when x equals 3. And last but not least, we can see that on Desmos as well if we put y equals 4 and we click on these intersections. So those are your hints to puzzle number 5.